technology has passed the one. So it can be done. The technology proved itself. And the next 10 years is the globalization. How do we take this globally at scale in a cost-efficient manner? So scale and globalization in the next 10 years or more. And then many of you in the audience, hopefully, will be part of that revolution. So that's the inflection point. This is the moment of what happened. So let's see what else has happened or is happening. If we look at Waymo, Waymo is also opening full driverless service for the general public in Phoenix. Phoenix is a more well-behaved environment compared to urban San Francisco. You could order similar to Careem, similar to Uber. You order a ride on Waymo, on the Waymo app. And probably in the future will be integrated with Google Maps. What else has happened is a partnership with Daimler on trucks. So the Google engine, Waymo engine, that serves a car could also be applied as a software and hardware stack to trucks for cross-state and interstate transport. What else has happened? Amazon has acquired Zoox, and Amazon is applying this for potentially, I mean, the idea is to apply it for the delivery of goods, people transport, and goods transport. Amazon also acquired a sidewalk delivery robot company from San Francisco, and called it Scout, that does sidewalk delivery for low speed. This is another company that got one of the first California license, actually first ever AV deployment permit in California. It's called Nuro. It's classified as a low-speed vehicle below 25 miles per hour, and it does grocery and food delivery. And hopefully we'll see probably Nuro here in Dubai. What else has happened? Tesla started to ship with a full self-driving hardware. And if you look at the compute power, there was a Tesla AI conference this past week. I think Tesla right now rank highest in terms of compute power, processing power. So Tesla is now driving and leading, pushing the envelope in terms of processing. They developed this hardware that operates on multi-sensor fusion, but without LiDAR. So Tesla is unique. It operates self-driving without LiDAR. However, the advantage that it has compared to Waymo that uses LiDAR is that Tesla has probably the largest fleet deployment in the autonomous vehicle with tons of data collection. Everything feeds into the cloud where you run very high and very sophisticated deep learning and machine learning models to understand, perceive, and do path planning for the environment in many edge cases. So it's not only the core case, but you have a long tail of edge cases with a high entropy environment where things can go wrong. And the person that, or the company that have this data is Tesla. What else has happened? In April this year, the RTA signed a deal with Cruise Automation for self-driving driverless service in Dubai that will start in 2023 with 4,000 AVs by 2030. And Dubai is unique in this region, probably the best infrastructure, the most progressive government, where we will see that probably the first deployment of AVs outside San Francisco or outside the US will happen here in Dubai. So quite an exciting place to be in. So this is happening, and you know the RTA is probably ahead of the curve here. So why is this happening? What are the trends, the ingredients that made this happen? So if you look at the past 10 years, trend to remove friction accessing data, connectors, API, getting this into the cloud. Now that the data is easily accessible, extracted out from sensors, from logs, from enterprise, it's fed into a data center. There's innovation in data center. There's innovation in big data, real data, batch data, and there's now that you have data and you have compute power, you could build more sophisticated ML models. So this has a cheaper AI learning, both at the cloud and inference at the edge. We also have robotics for the real environment. Now that you have machine learning and computer vision, I could apply this to understand the environment with robotics. I could apply this for movement, not only perception, but decision and control. And a car is a robot on wheel. And we had knowledge and talent diffusion, knowledge diffusion, with the accessibility of top courses from Stanford, from Google, from Facebook, all available almost for free at Udacity and Coursera. Many open source, many notebooks for free at GitHub. Now that you have a talent development, you have now capital chasing this talent, and you have a lot of funding startups about companies who left the Google brain. There is Aurora, there is Voyage, there is Neuro. Those three companies were at the Google brain, Google self-driving car project. So I have diffusion of knowledge. Those, you have an ecosystem that is development, talent ecosystem that is development, and you have venture funding behind it, backing it up. Together with easing regulation, Google is pushing for that, Amazon's pushing for that, for NHTSA, National Transport and Safety Government Body, and NASA, UTM, Unmanned Traffic Monitoring. And you have some regulation arbitrage where if Amazon wants to develop self-driving drone, it purchases private land, does the development there, and then allows the drone to, once the regulation allows, to fly over public land. So all of these ingredients are happening, and the pull is large total addressable market in terms of application. So it's an innovation in mobility, both for the transport of people and the transport of goods. So all of these are working together constructively. If we look at the go-to-market arc, we are starting in a well-defined controlled environment. And this started, I believe, 2009 or 2011 with Kiva. Amazon acquired Kiva Robotics. That's the robot, pick up the whole rack, moves the rack around. It's a well-controlled environment. You could do some rules, and you could do, it's well-behaved. So it's a lab, but it's a well-behaved lab. And then you have Saviok that moves in the hotels. You have some hotels in Vegas where Saviok is being deployed for delivering something for the room. You order something, get delivered via a robot. And you see this also in use in hospitals. The next thing that you see in terms of going from a spectrum of well-controlled to more, and from a safety spectrum, is the Sidewalk Robot. It's a low speed. If it runs into something, it can stop. If it bumps into something, the safety risk is lower. Companies like Starship and Kiwi Bots. You have private communities. Again, as you see, it's well-controlled, well-behaved, to more kind of into the wild, a less controlled environment. This is a gated community, private community. This is a company called Voyage. The founders were teaching the Udacity self-driving course, and this got acquired by Zoox this year. Sorry, got acquired by Cruise this year. So from private community to highways, highways is well controlled. There's not a lot of pedestrian motors like bicycles, strollers. You don't see this. So it's well behaved, less entropy, and Waymo and Too Simple are in this market. Low-speed vehicle with Neuro in a suburban environment, and then a geofenced, high-definition mapped cities like San Francisco or Phoenix with Waymo and Cruise. If once this is done, some of these are overlapping. Once this is done, we'll go to level 5, but level 5 is full autonomy, like any human being would drive a car, and maybe better in some areas. But I don't see full autonomy here yet. If we get L4 working well, and we get it to scale and work globally, then we'll be in a very good shape. So this is the go-to-market arc. But many of these share something in common. And that something in common is that if I pick up something, I have to take it all the way to destination to drop it off. There's no transfer in between. And this is similar to how the internet was working in the very early days. So right now, even in mobility of people, mobility of things, we're still behaving like the early days of the internet in the early 70s and 90s. And we're operating with manual package switching, take something out of the car or of the conduit and put it somewhere else. And we are operating right now like circuit switching for the same day delivery. This is the early days of the internet where there was circuit switching. I want to communicate from user A to user C. I occupy the whole physical conduit to send a packet. But the big paradigm shift happened when we moved from circuit switching to occupy the full conduit to use packet switching. And with packet switching, that's a topology of the internet. I could have user A and user B. I could aggregate them together using packet switching. I could do better utilization of the pipe, of the bandwidth. And why did this scale? How did the internet scale? What are the ingredients that are needed that help the internet scale? You need packet switching that we talked about. You need a standard header information. How do I route the packet or the package on the Atomnet? You need open communication protocols. Everybody can contribute on. You need algorithm innovation. Dijkstra or shortest path were created to route packets in a shortest distance on the internet. You need open DNS. And you need an ecosystem to develop, like Cisco and the Google of the world. And hopefully on the Atomnet, you need the Kareem of the world to drive this forward. You have hardware and software development. It's a whole stack, broadband access network. You have modems at the home, at the office. You'll have an Atom box, a modem at home, at the office, at each small and medium business, where you have a modem for atoms. And you have a separation of transport layer and application layer that made it simple, more abstract. You have decentralization, and you have millions, if not billions, of nodes if we count wireless phones, mobile phones. So you had an ecosystem that will bring this together, but this spans 2 decades at least, and this will continue to evolve. So putting this together, let's see the duality or the parallels between the bit world and the atom world. In the bit world, we have a modular transport. I have a packet switching with a header for each packet. In the Atomnet, we'll have packages with a header for each package. In the bit world, we have a multimodality transport network, different throughput, DSL, cable, fiber, Wi-Fi, and 5G. In the atom world, we have a motorcycle, car, van, a growing capacity of transport of the payload. On the bandwidth, we have a very well-studied information theoretic understanding using the Shannon formula, Shannon equation, with a bit per second. It's less understood now from a fundamental theoretical understanding about a unit package per second per meter. So this is a new innovation on the academic world that needs to happen to understand a unit package per second per meter from a capacity point of view, similar to how we do it on the information theoretic point of view for the bit world. On the header in the bit world, in the networking, we have a delay tolerant and delay intolerant. We have what's called MPLS, multi-protocol label switching. For each router based on the header, I could give it a priority or I could wait I could queue it and then send the packet later on. If the packet is delay tolerant, I could wait and pass I'm a Zoom call, I have a voice or video packets, I pass those, give them higher priority. In the atom world, we have delay tolerant and delay intolerant with perishable or hot or refrigerated foods. And in the cloud, we have the cloud and we have the edge. We have the data center. We have caching. We have content distribution network. In the atom world, we have a warehouse. We have a fulfillment center where you are closer where the demand is. And you have local, you have mobile or static hub, things that are moving. That's a hub that is static, or a hub that is moving, that is mobile. I came yesterday to Dubai. Coming from the airport, there was a big parking lot with a big Carrefour fulfillment center. This is a hub for Atoms. Why are we making the parallels? Because we, as you will see in developing the Atomnet, there's a lot of learning that we have that we could use and leverage from the bit world. As I mentioned, you could do the way we develop protocols, OpenDNS, separation of the transport layer and application layer. We need to do those in the Atom world. That's how we learned from the internet world and apply it in the Atomnet world. So it's a learning from the past that will accelerate getting this into production in the real world. On the endpoints, we have a router, gateway, and modem. We have an Atom router. We have an Atom gate, where for a Carrefour, a high throughput, similar to have a gateway, you have a wall where packages are in and out, and you need interfaces to run those at scale. The next home appliance, similar to your fridge, will be a smart box, an Atom box that sits outside. That's the interface between the home and the outside world. Not only you receive, but you could also send. Similar to the API here operates with a RESTful API with a get and put. You have a get and put on the Atom world. You get something, or you put something, you deposit something in the Atom box. Yes, we need to. And so I talk about next, what are some of the differences between the internet and the Atomnet. So I talk about the API, the RESTful API that made a separation between different modules. And then the robotics API will also need a robotics to exchange packages automatically. Right now, you need the human to pick up something, to get, you need the human to put. But that exchange could be fully automated. And this exchange is happening in warehouses. Amazon is driving that, and I'll show you some examples later. Have a question? Yes. Yep. So you'll see a lot of the logistics moving into smart logistics, and you start seeing the parallels becoming clearer. That the highway, you see all the cars are actually, you start seeing them as packages. And the car is, or a van is, most of the time is half empty. And you have multiple vans, half empty. Why don't you combine them together with an aggregation method? And there's an exchange of value, where there's a token, there's an incentive to allow them to work together and do exchanges. So we'll talk about that next. Yes? Yep, this is where the next slide we'll talk about on the blockchain approach. So what you're talking is about how do I, similar to the Ethereum, or I'll talk about the Helium network, it encouraged from a protocol point of view, there's an alignment of incentive with the miners. There's an element of incentive for the people who will deploy the access point on the Helium side. And similarly, there will be a protocol that will incentivize the people to operate autonomous vehicle for delivery, two autonomous vehicle from two different companies working together to exchange the goods because it's more efficient from them from a unit economics. And any autonomous vehicle, if you operate, let's say you buy one, you operate, you clean, you maintain, and you ensure that it has maybe higher throughput, more flexible. As long as you do some exchange, you got some tokens back. And if you remember in the blockchain talk, blockchain is permissionless. So you just buy it, as long as it engages, there's an admission into the protocol, it's permissionless. And similarly, what I was talking with Baber, Tesla, the Tesla network, you buy the car, but you put the car, the Tesla, on the Tesla network. Your car is now autonomously doing people transport, or maybe transport of goods, and you're getting paid while you sleep. Because 99% of the time, the car is, the asset is not being utilized. These are great questions. Yeah, these are great questions. So the AI camp is very exciting. Great to hear those questions. So what is the vision of Atomnet? Putting this together. You have the demand, like this is the Kareem super app. We do food delivery, we do grocery delivery, we do e-commerce delivery, we do pharmacy. You could do anything about the transport of goods. This is Kareem, could be also other than Kareem, any transport of goods. This is the demand in terms of application. This is the cloud, the Atom cloud. The Atom cloud, I have drones, I have sidewalk robots, I have vans, I have high throughput, like the fiber, which is a truck. And I could do delivery pickup from where you are right now, mobile. Hey, I have something, I need a coffee, I'm in the park, get it to me here. This is this use case. You want to deliver it to your home, you want to deliver it to your building, apartment, you want to pick it up from Carrefour or Safeway, you want to pick it up from the mall, there's an aggregation at the mall, there's an Atom gate at the mall, you have a warehouse, you could also do it in the airport for logistics, you could do it at the port, in Dubai port, in Jebel Ali. Everything will be connected, the supply chain will be connected together and automated. I believe we need a consensus. We need a protocol to be developed, and there needs to be some voting on the protocol. If this will be a DAO, a decentralized autonomous organization, there needs to be a mechanism to vote and append the protocol. And the case that that comes to mind, congestion. When in downtown San Francisco, sidewalk robots started to happen, you had a congestion on the sidewalks with multiple sidewalk robots companies. So it created a congestion and people were complaining about it. What you could do, you could tax it. So you could add a congestion tax. So if I see a lot of congestion, I just add a tax, and through this, I change the behavior. So it's a mechanism designed to change behavior through nudges like taxes and pricing. So you could start shaping the demand, shaping the behavior of the supply with financial incentives. Cool. So the Atomnet brings seamless access. Anyone can transact on the Atomnet, similar to anyone can transact on the internet. It's seamless, it's permissionless. It's ubiquitous transport, anything on wheels or that can fly, as long as it have an agent, then it could be on the Atomnet. It could fulfill work on the Atomnet and maybe get paid for it with a token. By creating an internet-like open network platform that connects, manages, and route multi-mode autonomous vehicle. Yes? Mm. So my view at the beginning, Kareem, for example, could kickstart this. could bootstrap it. So you have Kareem that manages this. Marketplace can manage this. In my team, we do manage supply and demand. We do matching. We do supply and demand shaping. And we can manage this as Kareem. As it evolves, this needs an ecosystem. So that's why the word open network platform is important. This cannot stay private, otherwise it will not scale. And we've seen, if we learn from history, why we're looking at history, at the internet history. When internet started to happen, you had something called walled garden. AOL, America Online, had a walled garden. So you could see, you could have everything within AOL. Verizon had to do its own. But this did not scale if we learn from history. So that's why you need an open network. A company can guide it and then open source it, and then it invites development by the open source community or a consortium of companies, similar to what happened with the internet. There's the internet body, governance body, to issue the protocol and approve protocols. Yes? I believe at scale, the public approach, there's an economy of scale that is to your advantage from a unit economics point of view. And that's why what we see in the industry right now, the open internet won versus a private closed internet or communication network. However, what you might do is that the added value could happen as an abstraction on top. So you could have the subscription because you're getting some added value, but then the fulfillment happens on the Atomnet. Similar to how you subscribe to something, you subscribe to Netflix, but the beauty or the reason Netflix succeeded is because most of the hard work was done by the ISPs, the internet service providers, to bring that huge volume of video data, of video throughput. And that's why you see the discussion now whether the ISPs needs to be, should we, what is the, should you keep the internet open or not? Whether you should do some preferential treatment. I think it's called internet, Baber, help me out. It's internet, the discussion about the ISPs, internet, like Netflix wanted to neutrality, internet neutrality. So the discussion on internet neutrality is about this. The internet is neutral of the application. And here the Atomnet should be neutral in terms of the application. Yeah. Yes, we'll get there. Yep. I like this audience. We'll get there. We'll talk about security next. So when we have internet security, you need Atomnet security, and that's integral in this. You need biochemical safety and security. Now, to get this is a true north, but to get this, there's a human in the loop. And will consistently be a human in the loop maybe for the next 10 years, if not more. So if 4,000 vehicles, AV vehicles, will be in Dubai in 2030, until then and beyond that, there will still be human captains involved to do the transport of goods and transport of people. So what are the benefits and downside? Cost per delivery with economy of scale will reduce, so this will be quite competitive from a unit economics point of view. Delivery time will reduce, would lower the coordination at the ingress and at drop-off. However, if you want to do the fastest delivery is always no transfer in between. Take it directly from point A to point B, but you're willing to pay more. And this is the optionality that is given to the consumer. You want something now, you'll pay more. You want to wait a little bit with more cost efficiency, you could also do with the right pricing. Poverty will decrease with less waste in the restaurant or the groceries before things expire. There are food banks that can coordinate this with the distribution of food. CO2 with better utilization and efficiency, multiple vans on the road, half empty, you will not have that. There's a more incentive for them to coordinate. It will simplify and improve the lives of people. That's the business of Kareem. Improve the quality of life. You don't have to worry about the daily things, getting things to your home or to your business. This could all be automated. You run out of food, you're running a business. We have the point of sale data, we have the accountant data, we have smart algorithm to know your inventory, and an order could be placed automatically. And there could be an automated order without a human. It's not an interface for Amazon. It's like an Amazon marketplace, but for the supply chain, where there's automatic bidding that can happen, and then you got the goods, you got the replenishment of your inventory automatically. So we open up access to many people and things. That's the IoT example, that's the fridge example, that's a restaurant example. All of that could be automated from a supply chain point of view because the data is there. New job creation in terms of cleanup, servicing, and maintenance. New factories, there's development of a completely new vehicle, what Cruise is doing with the Origin vehicle, package switching, robotics, interfaces, automated hubs, a Cisco of atoms, a big company will emerge out of this, several billion dollar company will emerge out of this. Atom boxes development, both on hardware and software collaboration. And this is the next industrial revolution for the next 20 years. Yep. Yep. No, EVs by design. And Amazon made, I believe, an order, several tens of thousands of vans, EVs. So there's movement towards electric vehicle. Supply chain automation efficiency, we look at the downside, the less traditional small and medium corner shops. A lot of those will be moved to the cloud, to hubs, caching, marts, and when you want something, your interface of what you want will be your phone, or your Siri, or Alexa. That's your interface for what you want. You go to the store for the experiential part to be in the store and meeting other people rather than meeting them virtually. We'll see less car and truck drivers. So with AV, the biggest sector in the labor force in the US are truck driver. So those are people, will be at risk when this happens. However, there's a transition maybe over 10 years for this to happen. And there could be some concerted effort to develop and upskill the existing truck driver who will be affected. Let's look at what's unique and what's common. We talked a lot about the commonality, how we could learn from this, but also let's talk about what's different. So what is different, what is unique is that bits travel speed of light, atoms don't. Right? So atoms, you could go 100 kilometers per hour, but you can't go at the speed of light. So this is big difference. You could cache things in the cloud, in the data center, but if you want it within 15 minutes, it has to be actually very close to you, not in a different country. Fault is costly. TCP/IP, if there's a collision, you could do a retransmission. There's no retransmission for packages. Fungibility in the atom world, you want milk. You don't care if you want the brand. You don't care where it comes from. There's a huge element of fungibility. In the packet, no, this is your voice. The packet will come from to you, travel all around the world. If there's a collision, there's a retransmission. But in the atom, there's an element of fungibility, especially for the consumer goods. Talking about safety, there's a chemical safety, regulation on movement of regulated and hazardous goods. What's happening on the logistics industry, the same protocols could apply in this case. So there's no reinvention of the wheel. There's already well-defined protocols for atoms transport that can be applied. Biosafety, germs, you probably need ultraviolet disinfectant, pest, odor, those are the things that the Atomnet needs to worry about that are extrinsic eccentricities and specific to the Atomnet. Food and grocery temperature preservation, those are needed for the Atomnet. Now, the Atomnet vision is clear. This will happen. If we extrapolate the arc of history, it is happening. Now, once it happens, I invite you to think what's next. Like probably our generation will continue to build Atomnet 1.0. Your generation will build on that and get Atomnet 2.0. So what is in 2.0? The 2.0 could be, I could do proactive population health diagnostics on a weekly basis. I could collect biosamples on a weekly basis. I could coordinate screening, cancer screening with liquid biopsy on a weekly basis. Just put it on the Atom box, forget about it. Gets done, you get the result. The whole logistics was handled, the whole complexity is handled by the Atomnet. Vaccine distribution, test distribution, and collections. It's not only distribution, but also collection at a larger scale. That's a great outcome, but this will happen with the Atomnet 2.0. We'll see this is affecting the regulation and the city infrastructure, automated stations, hubs in the cities, highways in the sky. You talked about mostly autonomous vehicle on the ground, but there is also self-flying drones, and you see highways in the sky. The farm-to-table example, you bypass the middleman, C2C empowerment, consumer-to-consumer empowerment, efficient food bank, and physical charity of physical item distribution, less need for a storage, you just rent it, you don't need it, put it on the Atom box, gets stored somewhere, or goes back to the store, you need it, press a button, comes back to you. IoT, machine-to-machine, supply chain, and marketplace. Restaurants, when an item inventory management, it transacts on a marketplace, the marketplace is powered by the Atomnet physically. Token-based, machine payable web, transacting both on the internet and the Atomnet. That's the incentive why you might have two different companies working together. If they all fulfill the same protocol, both of them will benefit. So you'll see a lot of economics development on protocol design and mechanism design. Ethical and traceable supply chain. You see this in the diamond industry with the Everledger and Tracer. These exist right now. SKU chain for supply chain, inventory traceability. This is not, in Carrefour has launched, you do a QR code, you could do traceability of the food item. So it happens already here in Dubai. New community and protocol-driven development economy, like Helium. Who of you have used Helium? Of how? We know about it. Like it generates tokens on behalf of the user based on the coverage it provides for. Yes, yes. So Helium is quite interesting because it's a blockchain, but does an incentivization that does not live completely in the digital world. It also lives in the physical world. And the learning from Helium could also apply to the Atomnet development. And this is what we could come up with now, but there's more that will come up. That is a very exciting future ahead of us. This is like a highway in the sky. This is like 2 airplanes, 2 drones that drive inside a tunnel. This is actually something I developed when I was at Stanford, but for the airline industry. The airline industry is heavily regulated. The FAA that regulates this doesn't move as fast. But you have a similar example with amateur drone for you want to go on a bike or a hike, and you put a drone that follows you. Skydio is one such a startup. So these are happening. A highway in the sky proposal is already in the works, and Amazon is leading much of that. That's the people network. That's Helium. That's the coverage in the US. Each is hexagon. That's San Francisco. Each one of them has at least 10 to 13 access points in each square, in each hexagon. If we look at, as I told you, I came yesterday from Beirut. This is Beirut. This is coverage in Beirut right now. This is coverage in Dubai for helium. It's completely decentralized, and it's working on economic incentive to drive behavior. So that's the beauty where that's the Linux open source grassroots development that is happening, and that's coordinating via protocol with economic incentive to drive the behavior. And that's the helium. It's more than a $2 billion market cap right now. So that's interesting. The learning of that could also be applied of how different autonomous vehicle could coordinate, and also autonomous vehicle and a human. The hybrid also approach could be facilitated by a blockchain decentralized protocol development. So I'll go very quickly on the elements of the Atomnet that are happening right now. Let's connect the dots. So we talked about, we extrapolated theoretically how things are happening, but let's see the reality on the ground. The future is here. It's not evenly distributed. It's not widely distributed, but you see it. This is inside Amazon. When you order on Amazon, the big fulfillment center is actually a data center of atoms, where you have quite sophistication, a lot of sophistication, in a very controlled environment. All of these are facilitated by Kiva robots. Look at this. And then there's a lot of optimization where the hot items are at the edges, the cold items not used a lot are actually in the center to minimize the travel time to the edge, to the interface. That's the interface right now. There's a human here, and Amazon runs a competition every year with the university to replace the human picker. That's the human picker being replaced by a robot, a company called Covariant. Founder is a professor of reinforcement learning at Berkeley. This is the robot that does the pickup. It's unstructured environment, unstructured random types of object, not well placed. And then you need an AI algorithm, a camera, computer vision, and the right motion planning for pickup and not break things. And then you have fetch robotics. You run in the store, you do scanning, and you could pick up items for grocery delivery, for Kareem, rather than have a picker, someone who's dedicated in the store. These are run around, do the aggregation, do the batching, and just have a human or a robot goes to the store, goes to the atom wall, pick up the box, already packaged for you. You already have a robot in Carrefour right now, in Ibn Battuta if you go, that does scanning and inventory assessment survey. So this is happening right now, and we'll see more and more of that with a one-to-end, with a more and more globalization. This is KUKA Robotics about automating the whole factory. The most interesting thing here, in my view, is that forklifts are being automated, are autonomous. So anything that moves, anything on wheels, once the 0 to 1 is there, you could put it and then automate a large object movement with forklift. This is you heard about Cloud Kitchen. This is Cloud Supermarket with Ocado. In the UK, similar to a data center, Atom Center for grocery items and the supermarket items. This is Fetch Robotics that we talked about for scanning and pickup. This is Sidewalk Delivery with KiwiBots, a Berkeley startup. This is Amazon Scout for Sidewalk Delivery. You see also a FedEx. Most of the traditional logistic company are interested in this development. This is a collaboration between Starship and Mercedes-Benz, where it's a multimodal exchange. Now we're talking about packet switching. This is package switching between two different modalities. Yes? Right now it doesn't. That's why you need a robotic interface, what we call the Atom Box. And the Atom Box could be done in a way, the robot will come, will do a put, similar to an API, will put a put, and there's authentication from a security point of view until you get the item. And if you don't bake in security, this also could be used for bad activities, dangerous activities, right? And so there needs to be a lot of traceability involved of who can use this and the right authentication behind it. This is Starship. Mostly in majority of the campuses, university campuses, you see it. It does drive around the world every 2 weeks. Put this in context, we at Kareem, we travel around the world 3 digits, multiple times around the world in a day. But it's not a fair comparison because we do long distance trip. We do car, on highway versus this is designed for shorter distances. Dedicated low-speed vehicle, we talked about Neuro, we talked about UDeliv. This is a super frame aggregation of multiple packages. So I have a hierarchy of packages for easier movement and transport and exchange. JD.com from China. So this is happening also not only in the US, but also in China. Multimodality package exchange that we talked about. Switch, Atom Switch, this is already in fulfillment center. The Aramex, the FedEx, the UPS of the world. This is Whole Foods when it got acquired by Amazon. This is in the original Atomnet picture that I showed you. I showed you this highlighted Atom Gate, Atom Wall. In the real world right now in Whole Foods, you have a full rack. These are the racks for food deliveries. It already has a header, you put a QR code, you take the package. These are delay tolerant, and the perishable items are in the rack of refrigerator because those are delay intolerant. This is reality. Right now, these are inside the store. In the future, that's the interface. It will be a wall with authentication for exchange. This is a static hub where you put items here, and then you do aggregation. A robot will come, a human will come, will pick multiple items at once and go to a certain residential community. This is caching, content distribution network at the edge with dark store. This is Amazon. You see some of the players here in the region are also developing that. And why we're doing this, we want to simplify people's lives. And we want them to have more time to do much more meaningful things in life. And we do this by connecting the world with seamless access and ubiquitous transport. And I'll end with this. You probably know what's written here. Who knows, shows of hand, what's written here? Marwa? So interestingly, when I came in, Emirates Towers, some of the code here in English was put at the entrance. So what's written here is this. المستقبل سيكون لمن يستطيع تخيله وتصميمه وتنفيذه. المستقبل لا ينتظر، المستقبل يمكن تصميمه وبناؤه اليوم. In English, future belongs to those who can imagine it, design it, and execute it. It isn't something you await, but rather create. This, as you enter here, Emirates Towers, it adorns the entrance here. Right? Right. And it adorns this, the Museum of the Future. The future, you are bold enough to imagine it and execute it. It doesn't await, it gets created. And we're lucky to be here to be able to create this. Thank you.